Alright, so in this video we are going to be talking about what energy actually does to the particles inside an object. And we're going to be talking about energy in terms of adding heat to something. So we can think of heat and energy as basically meaning the same thing. And in this video we're going to go over two types of jobs that energy or heat can do, and we'll also look at exactly what that means at the particle level. So our two jobs here are thermal energy, and phase energy. And I'm calling them jobs because it's really all the same energy. It's just energy can do two different things in these systems. It can either increase the temperature. If it's doing that, it's called thermal energy. Or it can overcome the attractive forces between the molecules, which that sounds confusing, but I'll show you what it means in just a minute. It can do one of these two things at a time. I think of it like jobs. It's all the same energy, but we call it thermal energy when it's making something warmer, and we call it phase energy when it's overcoming those attractive forces, causing something to melt or evaporate. I think it's also helpful to think of these like jobs because we call people a different title based on what they're doing. So it's like you might have a teacher or a doctor. They're still all people, but we use a different name for them depending on their job. So just like with our energy in daily life, I can't both make this video and tutor someone. You can't both study about energy and also work a shift at work, unless you have a really sweet job, but probably not, at the same time. So just like our energy, how we can kind of do one thing at a time and we get tired, we can think of chemistry energy that way too. It can only do one of these jobs at a time. It can do thermal energy, and then it can do phase energy. It can do one job at a time. I'm repeating that a lot because it will help us out a lot later. So now we're just going to talk a little bit about kind of what each type of energy looks like at the particle level. So you can see here we have our solid, our liquid, and our gas. The top picture is obviously like a place you might see them. And then our actual particles structures down below. So first of all, we notice in a solid, there's like these lines between them. They're locked in place. They're actually vibrating in place. They're all moving just a tiny little bit. But they're still locked in this structure. That's what these little lines represent. They can't move. So they're vibrating in place. And notice they're kind of far apart. A lot of people want to say that the difference between a solid and a liquid is that solids are close together. Look at that. It's just not true. The solids they're locked in place, but the liquids are actually pretty close together. The difference here is they can move past each other. That's why you can stick your hand inside a glass of water, but you can't stick your hand through a table. And then in a gas, they're so far apart that there's barely no attraction between them at all. And they're doing their own thing. So, in terms of energy, I'm going to switch to a different color. I'll make this energy part red. If we add energy to our solid, let's say maybe it's an ice cube instead of a diamond ring, because we're not going to melt down a diamond ring. We'll leave it as is. If we add energy, what's going to happen is it's going to make these particles vibrate faster and faster. That's thermal energy. It's making them go faster. If we keep adding energy, eventually, as these particles move faster and faster, I'm drawing the line. Imagine they're all moving faster and faster. I'm going to draw the breaking of lines down here just so you can see. Once they're moving fast enough, they're actually going to start overcoming this attractive force. And now we'll be talking about phase energy because these solid particles are going to start to pull apart from each other and move around more like a liquid. And that's what melting is. So again, we're adding energy into the system. It is going to make the particles move faster, and then it is going to break apart those attractive forces, cause them to evaporate. You can see that. We'll do another video about how to use these graphs exactly, but you can see that in these graphs. Our first part, we're adding energy the whole time. It's going to make the particles warmer first. It's going to speed them up. And that's why the temperature gets warmer. That's why it goes up on this graph, because this is temperature. And then those particles move around enough that it can overcome those attractive forces, then as we keep adding heat, it will melt. And once all of the ice or gold or whatever it is that we're melting has melted, if we keep adding heat, it'll get even warmer. So we'll talk more about these graphs another time, but you can see that it does one job at a time. It makes it warmer, it melts it, and then it can keep making it warmer if we want it to. So that is what we need to know so far about these two different types of energy. And again, they're not really different types. They're just two different jobs that energy can do.